During this tutorial, we will look at a question from MS 121 from the 2012 paper. We will solve question 1 part B 1 and 2 as shown on the screen. A sequence of integers x1, x2 all the way up to xk is defined recursively as follows: x1 equals 2 and xk plus 1 equals 5xk for k is greater than or equal to 1. For part 1 we must calculate a value for x2, x3 and x4. For part 2 we must deduce a formula for the nth term, i.e. xn in terms of n, and then prove its validity using the principle of mathematical induction. This slide shows part 1 of the question. We must calculate a value for x2, x3 and x4 since we know that xk plus 1 equals 5xk and x1 equals 2. To find x2 we must use and sub in the value of x1 into our original formula. So x2 is 5 times 2, which is equal to 10. We then repeat this process to find the values of x3 and x4. The next slide displays part 2 of the question, which is to deduce a formula for the nth term, i.e. xn in terms of n, and then prove its validity using the principle of mathematical induction. As we know, x1 is equal to 2, therefore we let the original formula equal 2. As anything to the power of 0 is 1, 5 to the power of 0 must also equal 1. So 2 multiplied by 5 to the power of 0 must equal 2. For x2 we again let the original formula equal 10. Therefore 5 must be to the power of 1, as 2 multiplied by 5 to the power of 1 equals 10. We repeat this process for x3 and x4, and we can deduce the formula that xn equals to 2 multiplied by 5 to the power of n minus 1. Now we must prove this formula to be true using the principle of mathematical induction. There are 3 steps involved in the proof by induction. Step 1 is to prove true for n equals 1. Step 2, assume true for n equals k. And step 3, prove true for n equals k plus 1. Step 1, we must prove true for n equal to 1. Using the formula we have deduced already, we sub in the value of 1 for n. That means that 2 multiplied by 1 is 2, which proves that this formula is true for n equal to 1. As previously explained, anything to the power of 0 equals 1. In this case, 5 to the power of 0 equals 1. Step 2. We assume true for n equal to k. This means we sub in the value of k for n into our formula. Our new formula reads 1/5 times 2 by 5 to the power of k. Step 3. We must prove true for n equal to k plus 1. Similarly to step 2, we replace n with the new value of k plus 1, so xk plus 1 is equal to 5 times xk. As we already know the value for xk from step 2, we sub this value into our formula. We simplify our answer to 2 times 5 to the power of k, so now xk plus 1 is equal to 2 times 5 to the power of k. We have proven true for n equal to k plus 1. Therefore, we have deduced a formula for the nth term for all values of k that are greater than or equal to 1. Thank you for watching our tutorial video, and we hope that it may help you solve future problems.